everyone. In this video, we're going to be talking about structures. Now, structures are a unique mechanism in C for organizing information. We've talked about a lot of different ways for organizing information through collections or arrays. So we know that arrays are collections of like elements. So if we want to group integers, we'll make an array of integers. And if we want to group floats, we'll make an array of floats. And if we want to group names, we'll make a two-dimensional array of characters so that we can have an array of strings. What structures allow us to do is make collections of related elements that aren't necessarily of the same type. If we make a structure, we can relate an integer and a string. Or we could relate a single character to an array of integers. Any kind of basic data type that we'd like, we can relate together using a structure, which is commonly abbreviated structs. As an example, we're going to be building a program about student records. So there's some certain information that, of course, we always keep track of for our students. We're going to write a program that has the student's first name, the last name, and their PID. So we want to keep all of this information related together. It's important that we know that these three pieces of information all belong to the same student. So we're going to use a structure to contain all of this information. To create the structure, we have to define it. This goes with our preprocessor directives. We have to define this new data type before we can use it. So it starts with the keyword struct for structure. And then we're going to give it a name. And then inside a set of brackets, we're going to identify all of the pieces that belong to the structure. So we're going to list inside the structure the first name, the last name, and the PID. So these will all be components of the structure that we're building. So here's the example. We might call this record, since it is a record of a student. So this would be struct record. Contains a first name, which is a character array, a string, a last name, which is another string, and a PID, which we're representing as the integer. So remember, your PID is the one that has the one letter in front and then the 7 numbers after that. So we're only going to store those 7 numbers as an integer. And like I said, these go with our preprocessor directives. So we'll see where they should be placed in our code. So our ultimate goal is to get a whole list of students and then sort them in alphabetical order like we would normally do with a list of students. So we're going to include our standard input-output library. In our string library, since we have first names and last names, which are strings, we might need to use some of those string functions. So after our header comment, after our included libraries, and after our defined constants, that's where we're going to place our structure definition. So this will be struct record, which contains a first name, a last name, and a personal identification number, or PID. After that is where we'll put our function prototypes, then our main function, and then our extra functions. So the rest of the program outline remains the same. The only thing we've added is this structure in between our constants and our function prototypes. Okay, so now that we've built our structure, we can start declaring things of that type. We've created our very own data type, just like an integer or a float. We've created our own called struct record. So if we want to create a variable of that type, we have to use the full name, the full struct record. And then we can give a name to our variable. So this, remember our standard variable definition is type variable name. In this, the type is struct record. You need both of those words to form the type. So the type is struct record, and the name is student. Okay, so anytime we declare something of type structure, we're going to use the keyword struct, then the structure name, then the variable name. For example, our student variable is of type struct record. So we know that each part of our structure has three components. It's got a first name, a last name, and a PID. So we need to be able to access those components that are inside student. So let's look at a quick visual. We know when we create something of a basic data type, memory responds by setting aside enough space for that particular variable. So for example, if we create an integer called num, it's going to go to memory and set aside a space that it will then label num. So this is the integer num, and now we can store anything that is an integer inside it. The structures are a little bit different. We've created something of type struct record. So it's still going to go to memory and set aside enough space, but it's going to set aside enough space for something of type struct record. So we're going to have an outer box that will label student, because that's the name of our variable. But it's going to have within it those interior pieces of the structure. So it's going to have a character array called first name, a character array called last name, and an integer called PID. So whenever we access student, that's going to take us to the outer box. So here's this space in memory. We've called it student, but it has extra things inside it. So if we want to access the student's first name, we need to go inside the box labeled student and access the character array called first name. And we do that with a dot. So this little dot between the variable name and the component name says to go inside the box to a particular component. So if we do student.pid, student takes us from variable declaration to the box, and the .pid goes inside the box to the actual component, which is an integer. And so then we're allowed to use this any place we would normally use an integer, including in an assignment statement, which is the example that's shown here. Go to the box labeled student, go inside the box to the component called PID, and assign it this value. So we're going to make up a student real quick. We want to be able to give them a name, but since names are character arrays, they're strings, we can't use the assignment statement. We're going to use string copy instead. And we're going to initialize student 1 with the name John Smith and the PID numbers 1 through 7. So now that we have a student, we want to build a function that will print out his information to the screen. Now, structures can be passed to functions like any of our other basic data types. If we're doing a pass by value function, then we can send it as a parameter, same as an integer. We'll have the data type and the name for the parameter. It's just now our parameter's data type is struct record. So we're going to build this pass by value function that will print out a single student. Now, since it's a print function, it doesn't need to return anything. We're going to make it a void type. It's called print1 because it's just for printing one student. It's going to print something of type struct record, and then we'll give it a name. So our formal parameter is called student. So we're going to print out two strings, probably last name first because that's usually how you see lists of students. So last name, first name, and then I'm going to print the PID on the next line. So last name, first name, and PID. We're going to go ahead and test this out to make sure it's working. Our actual parameter is going to be student 1, because we have two students, and that's the only one that currently has information in it. Okay. So here's how our information looks. We've got last name, first name, PID, and that is all of our information for John Smith. We're going to add this information from the second student. We're going to let the user give us that information for right now. So this information will go in student 2. And then we'll go ahead and print it out to make sure we've got all of our information read in correctly. Okay, so now we have two students. We've got John Smith and Meredith Jones. And what we want to be able to do is place them in alphabetical order. So in order to do that, we're going to need to be able to compare their names. And we know that the string library already has a string compare function for us. So we can use that as the basis for our student compare function. Because a lot of times we'll base it on the last name, but there might be a bunch of Smiths. So if they have the same last name, we then need to check their first name. And in some cases, they'll have the same first name, but they'll always have different PIDs. So that's how we'll build our function. So we need to take in two students. Both of them are of type struct record. So remember, this is our data type, struct record. And then we've got student A and student B. We're going to build it the same way string compare is built, where we return an integer value that indicates which one of these students comes first in our alphabetical order. So like I said, we're going to build this the same way as string compare. So we're going to return -1 if the first parameter should come first, +1 if the second parameter should come first, and 0 if we do have two of the same. So to be the same, they have to have the same first name, the same last name, and the same PID. So we'll do some comparisons. We're going to use string compare on the last names. So we're going to pass both last names to string compare. And string compare returns similar, negative value if student A comes first, and a positive value if student B's last name comes first. Okay, so we're going to compare the last names. If student A's last name comes first, return -1. If student B's last name comes first, return +1. Otherwise, they have the same last name. And we got to go check the first name. If student A's first name comes first, return a negative value. And if student B's first name comes first, return a positive value. And if they have the same first name and the same last name, then we've got to check the PIDs. Now these are just integers, so we can check using our normal relational operators. If this integer is less than this integer, return a negative value. If it's greater, return a positive value. And if they're the same, then everything has been the same all the way through, and these students have the exact same record, which means they're the same student. Okay, so let's go ahead and print these two students that we have in order. So if we compare student 1 and student 2 and get a negative value, then we want to print out student 1 first. And then student 2. If we compare them and we get a positive value, then we want to print out student 2 first, followed by student 1. And if we get 0, then they're the same student and it doesn't matter which one we print out. So we're going to run this one a couple times and with a couple of different inputs so we can make sure that compare is working correctly. So we know our first student is still John Smith, so we'll check something that comes before him in the alphabet. To see that the student with the last name Jones comes first. We'll check something later in the alphabet. To see that John Smith comes before Jack Thompson because Smith comes before Thompson. We'll add a little bit of granularity here. We'll check two people with the last name Smith. To see that Adam comes before John. And again, to see that John comes before Tyler. Okay. Now we'll check PIDs. We have two John Smiths, but the one with the smaller PID comes first. And the final thing is if we have the exact same record. It only prints out one student because there is only one John Smith with this particular personal identification number. So in order to do this for each student in the class, we would have to type in everybody's information. And a lot of times classes are usually pretty large, so we don't want to be typing in hundreds of students' names. So instead, we're going to switch to getting those from a file. So I have a file of student information, does last name, first name, then PID. There's only 5 students in the file, but it gives you an idea of how this would work. So we're going to make an array of type struct record. And these arrays are built the same as any other array of any other basic data type. Instead of having an array of integers, we're going to have an array of struct records. So the data type for our array is struct record. Give it a name, same as always, and then decide how many students we're going to put in there. Then, to access a particular element, same as always, we're going to index the array with square brackets, decide which element we'd like to go to. That'll take us to the individual box, and then same as always, the dot will take us inside the box to whichever component we're looking for. So here's a kind of visual representation of what that would look like. If we create an array of type struct record of size 5, then just like creating an integer array, memory is going to set aside 5 boxes in memory where each box is big enough for something of type struct record. So in each element, there's a box of type struct record, and we know inside each thing of struct record is a first name, a last name, and a PID. So if we were to go to the second index, we know that that means students points to the very beginning of the array. Going 2 spaces beyond that will take us to this box. Then the dot will take us inside the box so that we can access whatever particular element we're trying to reach. So we're going to go back to our program. We're going to swap out all of this initialization information for getting information from our file instead. We know our file only has 5 students in it, but in case we want to change that later, we're going to use num students as a constant. So we have 5 students, and we have a file that is called students.txt that we're going to open in read mode. So we're going to read in 5 students into our array. And they're organized last name, first name. So we're going to read in last name first. Go to the ith index of the array. Go inside that element. Store this in last name. Reading this from the input file pointer. Repeat for the first name. And finally for the PID. And then of course, to make sure that that's working correctly, we are going to call our print function to make sure that we have all of our information read into the program. We'll make sure we close our file at the end. Okay, so we haven't done any sort of organization yet, so we should get into our program the same names in the exact same order as what we have in our file. So we'll just double check real quick that everybody looks the same. So there are all of our students. What we have here is 2 lines of code, so not very many, that the whole purpose is to call another function. If we didn't want to duplicate this code very much, we could create another function whose whole purpose is to call this other one that we have. So this is commonly called a wrapper function. So its whole job is just to call print1 however many times we need to. So instead of having our for loop in main, we can call this wrapper function, who will then call our print function as many times as necessary to print all of our students, which we remember is controlled by num students. So we've got a couple of different examples of functions here. Print1 and student compare are both pass by value functions because struct records by themselves are not references. They're more like a basic data type like integers or floats. So since these are neither pointers nor arrays, those are pass by value. We also have this pass by reference function, which we know is a reference because we have this asterisk here. And we're using that instead of the standard array notation because we know arrays are already references. So this is a pass by reference function, which means if we had made any changes to students within the print function, then those changes would have been made everywhere. Now when you're using a pass by reference function on a single instance of a structure as opposed to an array, things can get a little bit confusing. So if we were to pass a pointer of type struct record, then in order to access that information, we would dereference it. So remember, we would use asterisk p, for example, to say go to where p is pointing. We do the same thing here with asterisk student to say go to where student is pointing and then access the first name there. But you can see that this gets a little convoluted. We have the parentheses, we have the asterisk, we have to encapsulate this information before we get to the dot. So they came up with an alternate syntax. This is something that we use a lot in Computer Science 1 when we're dealing with abstract data types. So you'll have a lot of pointers to structures. So instead of the asterisks and the parentheticals, they have instead this little arrow notation. It says student is a pointer, go into student and access first name or last name or PID, whichever. We're going to use this to build the rest of our student example where we want to sort all of the students into alphabetical order. So there's a few more functions that we need to build. We already have print and we already have compare. What we're going to need is some sort of swap function. And then we can add to that a sort, which we're not going to build, we're just going to grab a standard sorting function. We'll have sort call swap to put everything in the correct order. All right, so we're going to build the rest of our functions. We're going to build a swap function that swaps the contents of two elements of an array. We've copied in our sort function. And then to demonstrate that alternate syntax, we're going to build this function that is not strictly useful for our program, but just so we can take a look at that syntax. It's going to swap the PIDs of two individual students. Let's build that one first, just so we can look at it. So remember, the only purpose is to just demonstrate the pointer notation. There's not an actual reason for us to swap PIDs of people around. But what we'll do is we'll go create a temp value. These swaps look very much like they do for any other swap function. We'll create a temp integer, since PIDs are integers, and we'll set it equal to student A's PID. So since student A is a pointer, remember there are two ways that we can do this. We can dereference student A using the asterisk and this set of parentheses, and then grab the PID. Or we can use this alternate notation where we make an arrow out of symbols on our keyboard. In either syntax that we use, whether we've got the parentheses and the asterisk, or we're using the arrow, it has the exact same effect. We're going to swap these guys around. So we're going to take a look at that. So let's swap the PIDs of the first two students. That'll make it easy for us to find the results. So the one at index 0 and the one at index 1. And then we'll print them all again. Now we need to be careful with our parameters because even though students is an array, the element that we find at a particular index is not a reference. So we're going to have to give this the explicit memory address in order for this to be passed by reference. Okay, so now we've swapped the PIDs and we've printed out both lists, so we should be able to look at the first two people and see that their PIDs, John and Katie's, have changed locations. So our swap function works correctly. We're going to replace that with sort. We have to finish the rest of our program first. We've already copied in our sort function. So here's sort. And what sort does is it traverses the array of students until num students and looks for things that are out of order in the array. If it finds things out of order, it's going to swap them around. So this swap is taking place at two different elements of an array, which is going to make our swapping a little bit easier because there's not going to be a lot of pointers involved. And that's because this student, this name of the array, is already a reference. So we know that any changes we make to students inside this function are going to happen everywhere else, including in the sort function. So we're going to grab a temporary box of type struct record and let that hold the first index. Replace what's in the first index with what's in the second index, and replace what's in the second index with the temp value. So that should swap them around. And if we want to, we can test that before we rely on sort. And swap two people around. We'll give it the students array and swap the first person with the last person. So now in our list we should see that the first person, John, has traded places with the last person, Troy. So see how they've swapped locations. So since swap is working correctly, we know that we can let sort use it. So that'll be our final test. We'll call sort. And we should get all of our students in alphabetical order by last name. And that's our student record example. In our next video, we'll do another example that uses structures, and we'll start looking at something called nested structs. And I'll see you then.